Hello, welcome all. I've been holding this meetup for over a year now. Almost. This is number 10. Meetup number 10. Not quite once every month, but I try. So, yeah. Come on. There we go. So, next meetup. Astrop wants to hold next one. Tentatively at their new headquarters in the financial district. Sometime around the end of January-ish. I'm on vacation for most of the month this month, so yeah. If anybody's in San Jose and wants to drink beers, I like to drink beers in San Jose. And if we so happen to talk about keyboards, this is also wonderful. Yeah. So the agenda, I'll just do a quick overview of Inifity Keyboard again. We're almost shipping. And then some other things. So now finally get to the important part, which is all this stuff, the protocol conversion. This is the stuff that I really stayed around keyboards for. Like I probably would have left keyboards a long time ago if I didn't get into the protocol conversion. I don't do it so much anymore, but yeah. So Inifity Keyboard probably shipping around after Christmas, depending on things like signature plastics being stupid as usual. Yeah, the bent metal case has been a little bit annoying for production issues, but yeah, it'll turn out fine. It just configurator. So the whole point was, so once you get the Inifity Keyboard, you want to be able to configure keyboards. So the initial one will be a sort of a web-based kind of point-and-click kind of thing, like the Ergodox. But all the software I put into the keyboard, that's sort of basic. You can't really do fancy macros. You can't layer basically infinite number of layers. And so eventually there'll be something. But for shipping, you can make your basic layout. And if you want to do crazy stuff, you have to compile. Basically, you download the source code, you compile your layers, and it edits some text files. But eventually, we'll do a much fancier configurator. I have some things I want to do with the. Basically, the whole point of the Inifity Keyboard was to show off what I built in April time frame, which is this KLL, which is a sort of like a description of what you can do with a keyboard. So you want to have layers, you want to have macros, you want to do complicated macros, because a macro is not just pressing Control-Delete, it's pressing Control-Delete, then pressing 1, then pressing 5, then pressing cat. And then once you press that, you want to do something. You want to equivalently put out what you just did, or do you want to type like a novel? Do you want to turn a solenoid on? All those sorts of things. So that was sort of my whole purpose of KLLs, to be able to take these triggers and take these results and sort of take all the ways that people normally do things with keyboards and OS software and just put them inside the keyboards. You don't need any drivers anymore. You don't need any of that stuff. And just try to make it sort of standardized. So I've added a little bit of a compiler define. So right now, one of my issues with the Inifity Keyboard is that there's too much. When you want to define an infinite length macro, so that was sort of the goal. So I have a 32-bit integer for this counter. So eventually I had to proceed to each step. And 32 bits is big. It's basically longer than anything you'd ever consider for a macro. But I have to store, it's basically 4 times the amount of data to store a single thing versus, say, 8 bits. So I want to make this configurable so you can have a lot of things as opposed to a really long thing. So those things. Eventually, this will all just be under the hood. The compiler will just figure out like what's the longest you need and just assign that. Right now, it's sort of hard coded, but firmware, it's going pretty good. There's a lot of RAM optimizations and those sorts of things. But yeah, I did test. Well,
as a newbie, could you just cover what's the hardware in these keyboards? It's not just switches anymore.
So a keyboard from a basic, you go way back,
Yeah.
The keyboard is a bunch of switches,
Yeah.
and at some point you need to tell the computer what you're doing.
Yeah.
You want to tell something what you're doing, but it's very expensive to have a wire for every single switch to go out to the computer. So if you have 104 switches, you'd have to have 104 cables to your computer, and some keyboards do that. But this gets kind of ridiculous. So what they do is they assign a matrix of switches, and they scan them. So they'll power basically a row of switches, and then they'll sense each of those, basically columns. So columns versus rows. And so you'd be strobing these keys, and depending on what kind of switch you're using, capacitive sense or electrical is the easiest to think. But you have two contacts, you sense if it's there, and you're now going over doing scan, 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 really as fast as possible, basically. Now there's issues about doing this. A switch, it doesn't completely close 100% immediately. There's laws of nature we have to deal with. Debouncing. So some part of it has to control debouncing, and then so that was originally done on the computer, but to simplify work for the computer so the computer could do other more interesting things, they tried to offload that onto the keyboard. So do debouncing, sometimes even saying holding press release, so it would just send the characters that it needed. So it would be a full-on terminal, that sort of thing. So then it came along USB. USB is complicated. So there's no, like what I'm going to show today for the demo, reverse engineering, you cannot do with USB. This will not work because USB has an initialization sequence, and it depends. You have to understand what's going on. So if you want to reverse engineer, go actually take electrical engineering and masters, and that's a good start. You still have a lot of work after that. And so on top of that, now that I have this, basically, microcontrollers have gotten faster and faster and faster. In the keyboard we're shipping, the Inifity Keyboard, there's a 48 megahertz ARM core in there. I can do a lot of things with 48 megahertz. A lot of computers not too long ago were faster than that. So with all this extra RAM and extra space, I can start to offload what the USB spec says is the host OS problem, which is the layout. USB does not define a layout. According to USB, every keyboard is US ANSI, a normal US keyboard. This gets annoying at some points. You can't put weird characters. That's all up to the OS to deal with that. But now you have to leave it up to the OS. The OS doesn't necessarily handle as well. Windows doesn't do macros. I think you can do those in Linux, but you can't without custom software. You cannot define that. And it's because the keyboard understands the whole situation. You can basically do everything there, and then just convince USB that you're doing the right thing. So you get to massage the spec. So one of the massaging things I did was I did NP rollover. So I have 100% tested Linux, Mac, Windows, USB NP rollover. That's on the keyboard that's around here. I think I have one.
Flipping between boot protocol?
No, everything is on one protocol. They all work.
And
I actually physically tested Windows 8.1 is the biggest pain in the ass I've ever. It actually has useful error messages though. That's why. Microsoft is actually putting some effort into it. I was kind of surprised.
Deals with BIOS level.
Yeah. So it's two descriptors too.
Okay.
Quick overview. You save your boot descriptor, and then you have your whatever descriptor, which does all the in-key rollover, and it's up to the keyboard itself to figure out which descriptor you actually use. Basically, other than certain weird BIOS cases, the BIOS by the spec is required to tell you if it requires the boot hit spec. Now, that's all cases, but yeah. So everything I've used, this works. But there's a lot of other things it supports. So I also all the stuff I do works on basically all the teensies. So the AVRs, the ARM core stuff. So that's what I use with my dev kit. But I don't plan on making any keyboards with those because they're expensive. And they're just good dev kits. They're not actually good to build lots of stuff in. And the bootloaders are annoying. Yeah. So I have yeah. So this is a really neat find from, I have pictures later, but this is a membrane, single membrane keyboard. So if you look at the keyboards over there, there's a PCB. This uses sort of like the Model M style, where you have like a mylar membrane, which you'd have contacts. However, in this case, there's only one layer. This is printed on both sides of the layer. This right here is typical rubber dome. So you have a graphite pad that goes down. So if you bridge the contacts right here, it'll actuate. But what's this thing? That's a capacitive sense pad. So it's actually capacitive sense and a contact base in the same mylar membrane. I don't know why. I was like, what the fuck? Who the hell think it
Did the
is?
switches do both? Or is
No,
it
it's just one. The ones I have just have this. But they basically, yeah, I don't.
Imagine they're using it in two different pieces of hardware.
Yeah, exactly. That's what I would think. This was done by Unisys, which used to be Burroughs, and Xberry. But in terms of like how low can you go in terms of cost, it's pretty low.
Is that a gift? Because Unisys has a patent on that.
Probably, but patent does in like 30 years ago. As it was also really cool, it's hard to see here, that's an LED. It's soldered directly to the mylar membrane. I don't know how they did that. That's like it totally melts. Like, and there's a lot of solder there. It's not just like the little solder. There's a lot of solder. So this is really cool. And yeah, lots of pictures of things. Firmware features of that plan. So RAM optimizations. One of the things I want to do is LED triggers. So as I mentioned before, I want to be able to test like cat or one and do something. But LED states there's another kind of trigger. So you like if caps lock is activated, I should be able to use that as a trigger for macros. So that's one of them. I want to do on-the-fly macro defining stuff. That's what's I want to do is to be able to export the macros. So there's a little bit of work in there. Backlighting, I don't care about LEDs, but people do, and so I have to make it look cool. I have to think it's cool, so it should be impressive. I already have some driver chips that I've looked into and I'm using. Split keyboards. I want to do split keyboard. The Ergodox is neat. I hate I2C, the way they use it. It's so dumb and slow, and it's not even close to what gamers would even think is reasonable. And the bus is going crazy, and there's so much that can go wrong. So I have some other things and some other interesting things. And if people want features for things, if you bug me, I'll probably implement them faster. Or send me beers.